Next, let's look at some special functions which are called even and odd functions. Now, what are even functions? When I replace x in any function by its negative value, then I get all the values of x. Every place in the function which has an x in it gets replaced by that negative value. And then I simplify it based on the nature of the function. If I get back the same function which I started off with when x was a positive value, then that function is called an even function. Okay. Otherwise, if I get minus of the original function, that's called an odd function. And if I don't get either the same function or minus of the same function, that's called neither even nor odd. So let's look at the definition of even functions. If f of minus x equals fx, then such a function is called an even function. Example of some functions which are even are fx is equal to cos x, fx is equal to sine square x, fx is equal to x to the power 4, and so on. Similarly, when f of minus x equals minus of fx, then such a function is called an odd function. Examples of odd functions are fx is equal to, say, x cube. X cube is an odd function. Fx is equal to sine x, which is also an odd function. Fx is equal to tan of x. These are all examples of odd functions. So what are some properties of functions which are even and odd? Let's look at them. So functions which are neither even nor odd will give f minus x is equal to fx. For example, it's possible to get even that. There are very few functions which are perfectly even or odd. Most of the functions are neither even nor odd. For example, if I write 2x plus 1. So here f of minus x equals minus of 2x plus 1. And this is neither equal to 2x plus 1 nor is it equal to minus of 2x plus 1. Therefore, f of x is equal to 2x plus 1 is an example of a function which is neither even nor odd. Is the following function even, odd, or neither? So let's look at some simple examples on identifying functions which are even or odd. Fx is equal to x square sine x. So what is the test? Just replace every x in the function with negative value of itself. F of minus x is equal to minus x the whole square sine of minus x. And that is equal to x square into minus sine x. So that's minus x square sine x, which is equal to minus of fx. Therefore, this is an example of a function which is an odd function. So fx is equal to x square sine x is an odd function. Next, simple example on even and odd functions. Fx is equal to square root of 1 plus x square minus square root of 1 minus x plus x square. How do we identify whether it's even or odd or neither? Just replace x with minus x. So we get f minus x equals the square root of 1 minus x plus minus x the whole square minus the square root of 1 minus x plus minus x the whole square. So that's equal to the square root of 1 minus x plus x square minus the square root of 1 plus x square. So that's equal to minus of the square root of 1 plus x square minus the square root of 1 minus x plus x square. which is equal to minus of fx, and therefore the function is an odd function.